Find the general antiderivative of integral x square root of 3x squared minus 5 dx. And here we're going to use substitution. And in this substitution, let u equal what's underneath the square root. So u equals 3x squared minus 5. That would make du equals 6x plus 0 dx. And then we want to try to substitute u into this equation. So we do have our u right here, but we don't yet have our du. So we want to create the du, which is 6x dx, by multiplying by a constant. We already have x dx, so we need a 6x dx, which means we would have to multiply by 6 and also by 1/6. Okay, if we do that, then here is our du, 6x dx. Rewriting this in terms of u, we would have the integral of 1/6 the integral of square root of u du, which we can rewrite as 1/6 integral of u to the 1/2 du. Then use the reverse power rule for integrals. This will be 1/6 times u to the 3/2, and then we divide by the new power of 3/2 plus a constant. Dividing by 3/2 is the same as multiplying by 2/3. So all that remains is to simplify these fractions, to combine these fractions, and to replace u with 3x squared minus 5. So this will be 2/3 times 1/6 is 1/9, multiplied by 3x squared minus 5 to the 3/2 plus c. And that's just because we replaced u with 3x squared minus 5. For this next problem, we're also going to do u substitution. Find the general antiderivative of integral x times square root of x plus 5 dx. And we're going to let u equal x plus 5. That's going to make du equal to dx. I'm going to start replacing here because I see that we have dx, which we're going to replace with du, and I see x plus 5 under the root, which we're going to replace with u. So we'd have integral x square root of u du. Except now we have both x and u in this equation, so we need to do something else. We're going to try to replace x in this equation. We're going to do that by solving for x in terms of u. So if u equals x plus 5, then u minus 5 equals x. So we can rewrite this as integral u minus 5 square root of u du. Now that doesn't look like it helped us immediately, but if we rewrite this as integral u minus 5 times u to the 1/2 du, Now that we only have u underneath the square root, or u to the power 1/2, we can actually distribute that into the parentheses here. That'll give us u to the 1 plus 1/2 is 3/2 minus 5u to the 1/2. And now when we can integrate. Integral of u to the 3/2 is u to the 5/2 divided by 5/2 minus 5u to the 3/2 divided by 3/2. That was just using the reverse power rule, adding 1 to the power, dividing by the new power. This is 2u to the 5/2 over 5 minus 10u to the 3/2 over 3. And all that remains is to replace x in this equation, so u equals x plus 5. We get 2 x plus 5 to the 5/2 over 5 minus 10 x plus 5 to the 3/2 over 2, or over 3. So sometimes, as in the first example, we use u substitution because we see the derivative or the du of whatever we're trying to replace in a different part of the integral. And sometimes we can use u substitution to replace multiple parts of an equation so that we can write something that can be algebraically simplified and then integrated.